Welcome to part 2 of linear equations. In this video, we're going to be looking at examples where x, the variable, is now on our denominator. And so let's jump right into it. If I had 7 over x is equal to 7, how might we solve this? Now, we know this here is basically the same, or it is the same as 7 divided by x, which is equal to 7, right? So there's something inside of us that says, okay, well, let's times both sides by x, and you'd be completely right? Because if we had the example of 1 over 3 is equal to x, we would times both sides by 3, right? Perfect. But here we're going to times both sides by x. Amazing. So we get this. Now, what can we then see? Well, we know this x would cancel with this x, and therefore 7 is equal to 7x. And within our ideas of balance and everything coming into play, we then get 1 is equal to x because we divided both sides by 7, right? If you don't understand what I'm doing here, maybe take a look at my last video. I go into great depths in trying to explain what we're doing. But now let's look at a different example. So if I had a more difficult example, but still quite fun, we could say 1 over x plus 2 is equal to 1 over 10. Now you could just look at this question and say, whoa, I know what x is, but let's try prove it, right? Now, in this question, we must note that we actually have something called a restriction. Now, a restriction is a value that x, or our variable, cannot equal to. Now, we know that 1 over 0 is just, it's not possible, okay? And the reason for it's not possible because we can't put any number on 1 divided, or any number divided by 0, right? It just doesn't work out. And this here is quite a key concept of math, that 0 cannot go into any number. So it is not possible. And therefore, we know that x plus 2 cannot equal to 0. All right, perfect. And therefore, well, if we were to say that it does equal to 0, we know that thus x would equal to minus 2, right? Perfect. And therefore, we know that because it cannot equal to 0, it cannot equal to minus 2. And this here is our little restriction. Let's now continue with the question. Now, if we were to look at our last example, you might be thinking, oh, well, let's times both sides by x again. But if you were to look at it, you might realize that that would actually make the question more difficult. And it's not exactly what we wanted to do. So what do? Well, we actually times both sides by this entire denominator. And what does that help us with? Well, you'll see right now as I go through it. Because now I'm going to times both sides by the denominator, and it gives us x plus 2 divided by x plus 2 is equal to x plus 2 divided by 10. And these two would cancel out. Right, and you're left with 1 is equal to x plus 2 over 10. And this question is all of a sudden much easier. And from this, we can times both sides by 10 and say that 10 is equal to x plus 2, right? Because on the right-hand side, the 10s would cancel, and it would thus give us this. And then it's all of a sudden a much easier linear equation, and we can use our ideas of balance again, even though we've been using it throughout the whole question, and we can minus both sides by 2, and it gives us our solution that x is equal to 8, and therefore it does not equal to minus 2, so there is a solution. Now let's look at one final example. This example says that 7x plus 2 divided by x is equal to 7. So we know the denominator is x. So in this question, we can times both sides by x. But now you might be saying, hold up, we need a restriction, and you are completely correct. So what is our restriction in this question? Well, we know our denominator cannot equal to 0, so x cannot equal to 0. Perfect. So if you want to try this question by yourself, I mean, go ahead. I'm sure you can do it. So let's continue, right? So you would get that x over 7x plus 2 divided by x is equal to 7x, and we know these two would thus cancel out, and you get 7x plus 2 is equal to 7x. Now, we haven't really seen an example where we have an x on the right hand side and an x on the left hand side, but it's quite similar to all our other examples because, well, x is just the placeholder, right? So x times or 7 times any number that x represents is just the constant in the end of the day. So we can thus, minus both sides by 7x. So we can get minus 7x on both sides. And now you might be saying, hold up, that gives us 0x plus 2 is equal to 0. And therefore 0x is equal to minus 2. But 0 times any number is 0. So how does this work? And it doesn't, right? There is no solution to this question. And that sometimes happens in equations, right? There is no value for x that makes this equation work. There is no constant of an integer or a decimal. There is no possible number that we can put into x that solves this question. No real number that solves this question. And that's why there is no solution. Thank you so much for watching this video. I really hope it helped you. Have a good day.